In this next example, let's try to find out the missing side length by using the SSS triangle similarity theorem. So the question here says, find the value of x that makes triangle ABC similar to triangle DEF. Again, remember that two triangles are similar by using the SSS triangle similarity theorem if all three sides are proportional to their corresponding sides in another triangle. So let's try to compare these already. So to go from AB, so triangle ABC, to go from AB, which is equal to 4, we have to compare this to what corresponding side? To triangle DEF. We're going to compare this to DE, which is equal to 12. And then let's find out everything else that's corresponding. So BC equals x minus 1, and we're going to compare that with EF, which is 18, and then CA is equal to 8, and that we will compare it with FD, which equals 3 times x plus 1. So what I'm just doing here is just setting up all of these parts so that way it's easier for us to turn them into proportions, okay? So again, we know that two triangles are similar if all of their corresponding sides from one triangle to another are proportional. So let's compare it, okay? I'm going to make ABC. Let's make this our pre-image. And then the bigger triangle over here, this will be our image then. So again, in order for us to find the proportion, we have to put our image over our pre-image. So let's try that out. To get from AB to DE, I'm just going to set up a proportion as 12 over 4. And 12 over 4, 12 divided by 4 is just 3. So right now we have a scale factor of 3. Now this is where it gets a little bit tricky. Now we have our next proportion, 18 over x minus 1. We don't know what the value of x is going to be, right? So I'm just going to leave it like that. And here's another proportion that we don't know yet. We have FD over CA, but if we were to substitute those values, it will just be 3 times x plus 1 over 8, okay? So if we want to make these two triangles similar, what do you think we need to do? We already know that one of the corresponding sides, the proportion is going to be 3. So we just have to figure out from here and here, what value of x needs it to be in order for us to have it be 3. So what can we do? We can set up a proportion to be equal to it. We can say that 18 over x minus 1 has to equal the scale factor of 3. Or we can do 3 times x plus 1 over 8 also has to equal 3. So that way they all have the same proportion, right? Let's go ahead and solve this first one up top here. So if I have this, we can just cross multiply. 3 is the same thing as 3 over 1. And when we cross multiply, what are we going to get? We're going to get 3 times x minus 1 equals 18. And now we're just going to solve for the variable x here. So we're going to distribute this 3. So now this is going to become 3x minus 3 equals 18. What are we going to do to both sides? We're going to add 3. So 3x equals 21. And then we're going to divide both sides by 3 to isolate the variable x. So x equals 7. Oh, well, x equals 7. Let's go substitute that back into this original proportion here. So if x equals 7, then 3 times 7 plus 1 over 8 should equal 3. Let's see if it does. 7 plus 1 is going to give us 8. So 3 times 8, we do parentheses first, over 8. And then 3 times 8 is 24, and 24 divided by 8 is going to give us 3. So far so good. We have the same scale factor. We have the same proportion here. I'm going to move this off to the side. And let's go ahead and solve for this last one then. 3 times x plus 1 over 8 equals 3 over 1. So let's go ahead and cross multiply this. So 8 times 3 is 24. So 24 has to equal 3 times x plus 1. If we cross multiply, it's just the same thing. And now we do the same exact process. Let's go ahead and this time I'm actually going to not distribute. I'm going to divide both sides here by 3. So 24 divided by 3 is going to give us 8. And 3 divided by 3 is just going to leave us with x plus 1. So it's going to be x equals x plus 1. And then what do we do to both sides of the equation to isolate the variable x? We're going to subtract 1 on both sides. So again, look here. It says x equals 7. Oh, x equals 7. If x equals 7 again, then if we substitute this value, 3 times x plus 7, sorry, it's actually supposed to be 7 plus 1. 7 plus 1 over 8, we get 3 times 8, which is 24, and then 24 divided by 8, which equals 3 again. So what is going to be the value of x that makes these two triangles similar? It's going to be x equals 7. And everything that we just did, we just showed our work. So since we have a 3 over here as a scale factor, we have another 3 over here as a scale factor, we have another 3 over here as a scale factor. Based off of the SSS triangle similarity theorem, these two triangles are similar and x equals 7. Okay, that's it, bye.